Hello friends, now we will see one university question on gantry girder design procedure. On gantry girder design procedure, repeatedly university questions are being asked. Explain the step-by-step procedure in the design of gantry girders. Also explain the loads that will be considered in the design. This is for the year April 2017, November 2017, May 2016, November 2016, etc. for Anna University. Not only for Anna University, for other university also, this question is repeatedly being asked. And here I have explained the design procedure for the gantry girder with due notations, and I have ensured that the procedure is given in a concise manner so that it can be easily followed for the actual design calculation also. This gantry girder is the unit which is supported in an industrial shed between the two columns. The gantry girder will be running along the length of the building. The gantry girder is supported on the columns by means of the bracket. Then there is one crane girder. It is in the transverse direction. It is in the cross direction of the building. This crane girder is having one unit called crab. That unit crab is having a hook for lifting the loads. And this unit crab will move on the crane girder through the bottom flange of the crane girder. Crane girder is also an I section, and crab will be moving on the flange of the crane girder. Crane girder is in the transverse direction of the building. Gantry girder is in the longitudinal direction of the building. Now we have to calculate the loads transferred to the gantry girder. Now this crane girder is lifting the loads and transferring the loads to the gantry girder. Here AB is the crane girder, RA, RB are the two gantry girders on either side of the crane girder. On this gantry girder is running along the length of the building. Now the load lifted in the crane girder can move very close to one side of the building. There will be some approach distance, minimum clearance will be maintained, beyond which this load lifted cannot move closer to the column. So as close as possible, this load is placed closer to one end. For this position, we have to calculate the value of RA. Here RA is calculated due to crab and the load lifted. Crab is the unit which is moving at the bottom flange of the crane girder. This is crane girder. In the bottom flange of the crane girder, this crab unit will be moving by lifting the load. So RA is calculated by placing the load due to crab and load lifted as close to one column as possible. This RA is calculated. This is represented as W1C. W1 is the wheel load and C is transferred from crane. 1 is load case 1. This RA by 2 is calculated by placing this crab and load lifted as close as possible to one column. Then what about the crane girder weight? This crane girder weight will be uniformly distributed. 50% of the load will go to one gantry girder on left hand side. 50% of the load will go to the other gantry girder on the right hand side. But this crane girder will be having two wheels on left hand side, and on right hand side it will have two wheels. So 50% of the load is transferred to one gantry girder, that is half of 1 by 2, 50% of crane girder. Then again two wheels are there. We are calculating one wheel load, therefore it is 1 by 4 times weight of crane girder. And there are two wheels. That is why, see, this RA is the load transferred from the crane girder to the gantry girder. And RA is divided by 2 for getting the wheel load because there are two wheels. This gantry girder, this crane girder will be moving on the gantry girder by and crane girder is having two wheels. The two wheels will keep moving on the gantry girder. That is why here it is RA by 2. Here weight of the crane girder RA is total weight divided by 2, and two wheels are there, so 1/4 of weight of crane girder. And total wheel loads, that is total wheel load transferred from the crane girder WC is equal to W1C plus W2C. You have to add these two loads, and this is the total wheel load. And this WC, as I said, there are two wheel loads. Suppose if the spacing between the two wheel loads is A, then you have to place one load at a distance of A by 4 from the midspan of the gantry girder. Span of the gantry girder is nothing but the distance between the columns. In an industrial shed, the gantry girder will be running along the length of the building. The gantry girder is supported on columns. This is the gantry girder. This is one column. This is one column. These columns will have brackets, and this gantry girder will be resting on the brackets. So the gantry girder is supported on the columns by means of the brackets, and it is running along the length of the building. The wheel loads are placed such that one wheel load is at a distance of A by 4, where A is the midspan distance between the two wheels, and this distance A by 4 is with respect to the midspan. For this position of the load, you calculate the bending moment under the load. Calculate the bending moment under the load. Calculate the reaction, then this reaction into this distance will give the bending moment. Calculate the bending moment under the load. That bending moment is denoted as mx1, and mx2 is due to impact effect. The loads are suddenly lifted. So if it is manually operated, 25% is the impact effect. So multiply this mx1 by 0.25, 25% addition. Then mx3 is the bending moment in gantry girder due to self weight. That is equal to W1 into L square by 8. L is the span of the gantry girder. That is distance between the two columns. Then mx4. This gantry girder is having rails on the top flange on which the wheels of the crane girder will move. So that rail weight is W2 into L square by 8. This is the bending moment due to weight of rails. Then all the bending moments, mx1, mx2 plus mx3 plus mx4. All these loads are acting in the vertical direction. Bending moment is about major axis. All these loads are acting in the vertical direction, and bending moment is about x-axis, major axis. Now we have to calculate the surge force. Surge force is acting in the horizontal direction. Surge force is acting in the horizontal direction, as you can see here. This is the one end of the gantry girder, which is supported on the column through bracket. This is the other end of the gantry girder, which is supported on the column through the bracket. Then surge force is acting in the horizontal direction. It will cause lateral bending moment. Earlier we have calculated the bending moment due to various load cases. They are all vertical loads. It will bend in the vertical direction. The surge force is due to application of brakes, and it will cause loads in the lateral direction. It will cause lateral bending moment. And this surge load is 10% of the crane capacity plus crab. This crane capacity is nothing but the load lifted, then weight of the crab known. So 10% of that should be taken. There are two wheel loads, so divided by 2. Ws is the surge load. It is calculated as 1 by 2 into 10% of crane capacity plus crab. Then My is the load due to surge loads. This is calculated in proportion to the wheel load which we have already calculated. Wc is the total wheel load. For that, the bending moment is mx1. This is the total wheel load Wc, and mx1 is the bending moment due to Wc. Now Ws is the load acting in the lateral direction. It is calculated in the proportion. So Ws by Wc into Mx1. This will give the bending moment due to such a force. We have to choose an appropriate section from the steel tables. The section is built-up section with the plates at top and bottom plus one channel. Normally ISMB 600 plus one flange plate at bottom, one flange plate at top, plus ISMC channel 400 will be provided. This ISMC channel 400 is provided because it has to be made stronger for resisting the lateral bending moment. The such force will be acting in the lateral direction. It will cause lateral bending. For making the beam stronger, we are placing the channel in this shape. For this composite section, the properties are readily available. IXX, IYY, all these properties are available. And FBC is the allowable bending stress. It is taken as 0.66 F5. And for all the rolled sections, the working stress method, the allowable stress is 0.66 F5. Because there is no flange buckling, there is no web buckling. The section will be either compact or plastic. Whether it is compact or plastic, full stress is allowed. We are using the working stress method. So it should be 0.66 F5. Because for all the rolled sections, web buckling is prevented. It is less than 67. D by T ratio. Web buckling is prevented. D by T ratio is less than 67. The flange overhang will be less than the specified ratio of 10.5 for the compact section. Therefore, 0.66 Fy is taken as in the case of working stress method. Calculate the bending stress due to the vertical bending moment, that is Mx by Ixx into Y, the topmost distance. Then calculate the bending stress due to lateral direction, My by Iyy into X. X is half of this distance. Suppose you are providing a channel of ISMC 400, then this will be 200. Then add the stress due to vertical bending and the lateral bending. The total stress should be less than the allowable bending stress. Allowable bending stress is 0.66 Fy. Most probably 0.66 Fy will be used because there is no flange buckling or no web buckling as in the case of rolled section. Then we have to calculate the shear force due to various loads. Now these V loads you have to place at one end of the gantry girder. At one, this gantry girder is supported on the columns by means of the bracket and place the load such that one load is at the one support, that is near one column. Then the other load will be A. A is the spacing between the two wheels. For this position, you calculate F1. This is the shear due to wheel loads. Then shear due to impact effect will be F1 into 0.25. F1 is the shear force due to wheel loads. 25% of is the impact effect. Then F3 is the self-height shear force, that is W1 into L by 2. F4 is the shear force due to rail load. Wt is the intensity of the rail load into L by 2. This is the shear force due to rail load. The total shear force is F1 plus F2 plus F3 plus F4. D by T ratio will be definitely less than 67. Therefore, the allowable shear stress is taken as 0.4 Fy. Fy is 250 Newton per millimeter square. And allowable shear stress is equal to 0.4 into 250, that is 100 Newton per millimeter square. The actual shear stress is equal to the total shear force F1, F2, F3, F4 divided by T into T. This should be less than the allowable shear stress TAB. Then this is the check for the shear. Already we have seen the check for bending. Now this is the check for shear. And we have to provide the bearing stiffness at the support locations. And we have to provide lateral restraint for all the gantry girders. For all the gantry girders, lateral restraint is provided. How the lateral restraint is provided? Gantry girder is supported on the column by means of the bracket, and there will be one longitudinal beam which is connecting the column to column. This longitudinal beam and gantry girder are running parallelly. Gantry girder is supported on the bracket, whereas the longitudinal beam is supported on the column and from the center point of the column to center point of the other column. Therefore, these two are running in the longitudinal direction. They are parallel and they are connected by means of the plan bracings. Therefore, Fy should be taken. We need not calculate FBD. All gantry girders are laterally restrained by means of plan bracings. And we have to calculate the deflection due to all uniformly distributed load. 5 by 384 into W1 plus W2. This is the gantry girder load. This is the rail load. This is the deflection due to uniformly distributed load. Then the wheel load. Wheel load is placed at a distance of A from the midspan, where A is the spacing between the wheel loads. And this is the formula for the deflection due to the point loads. Here X is equal to L minus A by 2. The deflection so calculated should be less than L by 750. The allowable deflection for gantry girder is L by 750. For the normal beams, it is L by 300. For the gantry girder, the allowable deflection is L by 750. This completes the design procedure for the gantry girder. This question is being repeatedly asked in all the universities. And I am also requesting you to visit my website, https://rdinsite.wordpress.com. https://rdinsite.wordpress.com. In this website, more than 500 detailed university questions and answers are available on the structural engineering subjects: RCC design, steel design, strength of materials, theory of structures volume 1, volume 2, and also the matrix methods of structures. All these subjects are covered. Almost 500 detailed university questions and answers are available. And the download is free. And this question is also available in this website. Also, I am requesting you to visit my channel, YouTube channel regularly. The name of the YouTube channel is RGN Class. Thank you all for your patient listening.